Okay, so I've got another, looks like a logistic function, and I need to figure out something about the ants in the colony. So how many ants are present initially? How do we find the initial value?
500.
No! All right, let me say it one more time. To find the initial value, we let x be zero. And you guys, that is something you could memorize, and some of you will, but it needs to make sense. The original value is when x is 0. That's the starting. So, if I plug in 0,
O-R-I-G-I-N-A-R.
let's see, that's just going to be easy if I put in 0, right? So then I'll go to my calculator. And I got 20, what are these? Are these creatures ants? I'm going to say 24 ants. Because it's 23.7 and I can't have 0.7 ants. Right?
I mean, not living ones.
Yeah. How many ants were present after 4 days? Well, now I'm going to plug in. Oh, wait, what was my exponent? 3 minus 2. So that was -1.
Oh, negative, that's how, yeah.
Right? So I can go ahead, I can type that in. So 500, yep, 500 divided by second ln -1. I got 366 basically ants. After how many days will there be 342? So 342 equals 500 over 1 plus e to the 3 minus t. So last one we did one of these earlier, and you decided you were going to intersect, do intersections. That absolutely worked. Wherever they cross, look for the x value, and that is how many days? And what is the maximum number of ants? 500. The limit to growth is 500. So I did 4 days and got 366. As I do more and more days, I'm going to be getting closer and closer to 500. Never going over 500, but I'll get closer to it. The limit. Yeah.
So you never can hit 500 or go
It's
over.
called the limit to growth.
0, 5,
I'm not sure what that means. Y equals 500 would be your asymptote. Okay. All right, what else? Joe?
1C on 5.
On page 5,
Yeah.
1C.
Yeah.
Okay, now Joe,
Like,
come on now.
Come on, Joe, like.
3x.
All right, we've already talked about this. What is the first thing that has to happen?
Bacon.
Oh, okay, no, you do not cancel the LNs.
No,
You can cancel logarithms, but only when you have log equals log. Is that what I have? No, standard doesn't count. It's not what I have.
3x over 6.
So these have to be put together into one, stop talking, into one logarithm. Okay? Now you can cancel them. That's the only time you can cancel them. Okay? So then 3x over 6 equals 70, so 3x equals 420, and x equals 140.
Yeah.
okay? So do not
I love when they cancel.
cancel your logarithms unless you have one on each side. Log equals log. And if you don't have that, put stuff together so you do have that.
So nice when you get it there though.
It is so.
Isn't it so easy?
We do F on that page.
F on that page is exactly the same start,
A little different.
but the problem is not the same at the end. But the first part of the problem is the same, because we have two logarithms, and we're not allowed to. So we're gonna have to put them together. How are they gonna go together?
Or
They're gonna
distributed.
go together as
Multiplication.
log base 2
4x plus 20.
of 4x plus 20. That's exactly right.
U minus.
Why did they go together as a multiplication? Because the logarithms were added. Now, do we have log equals log?
No.
No, so we're not dropping anything. What do we do when we have one logarithm?
Oh.
We move. So 2 to the 4th equals 4x plus 20. 16 equals 4x plus 20. 4x, net x equals -1. Now, once you go back and look at the problem, it's all good. That answer works, it's fine. We're all done. X equals -1.
Is there times it doesn't work?
Yeah, you can't take the log of a negative. But I'm not taking the log of a negative because I'm adding it to 5 in the
But
problem.
like, you know how we had to, in other chapters, we had to check back to see if it equals 0.
That doesn't, that's not what, I cannot take the logarithm of a negative number. But in this case, I am not taking the logarithm of a negative, I'm taking the logarithm of -1 plus 5, which is a positive number. So it's all good.
Can you 7 and 5?
Huh?
7 on page 5.
7,
Yeah.
how long compounded quarterly? All right, what formula am I going to use? There's more than one.
A equals B, or A equals R. Her equals P. Run the right
Oh, you wanna know You are so far off the rails, it's not even right.
All I know is PV.
We're talking about on page 5, number 7. So page 5, number 7. Okay, now, we're gonna stop, I want everybody to stop talking and listen, because this should not be confusion. If you pick the wrong formula, you are wrong. The question is wrong. No partial credit, I don't care. So you gotta get the formula right. I heard somebody say PV. All right. When is the only time that PV and FV are used? If you are making payments. That is what you zero in on. Read the question. Number 7. How long does it take 654 to run 9876? Stop right there. Am I making payments?
No.
No. So it will not be FV or PV. So then I continue reading. Compounded quarterly. That is not per.
P equals 1 plus
Per
4
is compounded continuously.
It's the other one.
Stop talking. This is not hard. If you're paying attention, we should not be confused. In fact, I'm embarrassed on your behalf. This should not be confusing. Payments, FV or PV. If I'm making payments to save for something, it's FV. Stop talking. If I'm making payments to pay off a debt, that's PV. All right? Serious, it's that easy. If I am compounding continuously, or if it's a problem that doesn't involve money, I will use PERT. If I am compounding, it's a money problem, and I'm compounding quarterly, monthly, daily, yearly, semi-annually, whatever, then it's my compound interest formula. Okay? Now, that's it, folks.
So,
Figure it out, get it learned.
so population is PERT.
Yes, because it's not money.
Yeah. It's the only one that's not money. Yes.
Okay,
Yes.
so
Way to go, Daphne.
we have now settled on
That's
this
what I
formula.
said.
And I want 654 to grow into 9876. Okay, the interest rate is 0.0575. There's another mistake I've seen on homework papers. Interest rate must go in as a decimal. So don't put 5.75, put 0.0575. Compounded quarterly. And I want to know how long it takes. Okay? So the first thing I have to do, I know that eventually I'm gonna need a logarithm, because anytime my variable is up here, I need logarithms to bring it down. But that's not what happens first. What happens first is I'm going to divide.
It's 14.
Now, I'm ready to get that exponent down so I can divide. So I'm gonna take the logarithm of both sides. So I'm gonna have the log of this fraction. And it's gonna equal 4t log of this thing. And I know it's ugly, but I'm not fearful at all. I know exactly what I need to do. I need to get this by itself, right here. Which means I'm gonna have to divide by 4 and divide by that.
Yes.
So I'm gonna figure out what this is, type that in on my calculator. Log 9876 divided by 654. And then start dividing. So I've got this. So now I'm gonna divide by 4. And then I'm gonna divide by that logarithm. And I got 47.552 years. Okay? You don't have to write a bunch of stuff down here. Once you figure out what you need to type in, just stop worrying about writing it down and just start typing it in. All right? What else?
Yeah.
Kellen? Two what? B? 2B says, this is another right a logistic function. So we have to remember what it is we're going for. What does a logistic function look like? Okay, so this is my goal. I'm on page 5, 2B. I have a logistic function. The limit to growth is 60. So the 60 goes
On top.
up here.
Y is 40.
The initial value is 40.
So put
Which
0 in for
means
X.
when I put 0 in for X, I'm going to get 40 for y. Well, c to the 0 is just 1. So I'll multiply this over.
Wait, why did that just cancel?
So it looks like 40b equals 20 and b equals 1/2.
Yeah.
So then I can put 1/2 right here. So now what do I do? So put 20 equals 60 over 1 plus 1/2 c to the second.
Times both sides.
So I'm gonna bring this over, so I have 20 plus 10c squared equals to 60.
Yeah. Minus 20.
So 10c squared equals 40.
So it's 2.
C squared equals 4, and C equals 2. Alright, I'll do one more. I need to take attendance first because I forgot to do that. So, let's see, we got Caitlin, Tyler, Jalen, Keller, Aiden. We don't have Aiden. We have Coleman, Delaney, Edwards, no Lexi. We got Jake and Joe, Jaden left, Grace, Dana, Colin, Jackson, Sam, Julian, London. I have Luke Reyes. All right, did you find one more? What's our last question? What do we do?
Make it a good one.
Huh?
I can't add. It's a draw.
I'll take it.
What equation do you use number 6 on page 4?
Page 4,
Quarterly, does it A?
page 4, number 6. How long will it take to quadruple an investment? Okay? So, this is one of those where you can pick whatever you want, but Charlie's already said I'm gonna start with 1 and end with 4, and isn't that what happens when you quadruple? You can start with 2 and end with 8, it doesn't make a single bit of difference. However, this is the formula I'm gonna use right here, because what is the key in the problem? It says what?
Compounded quarterly.
Compounded quarterly. Compounded quarterly. As soon as you see those words,
Compounded.
right there. So, Charlie already said he wants to put a 4 here and a 1 here. What is my interest rate? Which one am I doing? 6? So 0.024. And I want to know how long it would take. This is exactly like the one we just did.
So we have the log,
First step is to divide by this number. Now, in our case, it's a 1, so it doesn't really matter. But if you pick something else, you need to divide by that number, okay? That's your first step. Don't erase it, divide by it, okay? Then, we're gonna log both sides. And we'll pull that exponent off. And then we're gonna stop here and think about what has to be done.
Double D, double divide.
Double divide.
Double D.
Because we've gotta get down to just plain T. So we're gonna take our log 4 and divide it by 4 and divide it by that. And it's gonna take 57.94 years.
On the test, we're doing this around.
It'll tell you how to. All right, so two things in your math life. Math league in the morning and test in class.